So I will try to solve today's problem. So 1 second left. Let's refresh. It's available now. I think it's a medium rated. Yeah, it's a medium rated problem. There exists an infinitely large two-dimensional grid of uncolored unit cells. You are given a positive integer n, indicating that you must do the following routine for n minutes. At the first minute, color any arbitrary unit cell blue. Every minute thereafter, color blue every uncolored cell that touches the blue cell. Below is a pictorial representation of the state of the grid after minutes 1, 2, and 3. So first minute he has done this. So in the second minute, every square that touches that initial square, he colored all of them, and then he added four more. So not four more, eight more. So okay, now I'll have to just answer what return the number of colored cells at the end of n minutes. So I think for the first time I'm doing one, so let's try to have some pattern. So first minute one, then I'll do what? Then I'll do four more. So I'm adding four. Initially it's zero, then I'm uh, adding four more, and then adding eight more. So and then adding eight more. 1 2 3 4 5 6 7 8, and then what? Then I am adding 1 2 1 2 3 1 2 3 4 5 6 7 8 9 10 11 12. So and then I'm adding 12. Is it that I'll add, I don't know, can I copy this image? Okay, I could. Okay, let's try to do something. Let's try to color it somehow. Okay, yeah. Okay, yeah. Okay, yeah. So I'm adding 12 more when n equals to 1 2 3 4. When n equals to 4. So yeah, here, and and one more here. So 3 6 9 and 12. 9 and 12. So after that, what will I do? I will be adding I will be adding 1 2 3 4 5 on one side, 5. So 1 2 3 4 5. Then I'll do another 5 here. 1 2 3 4. No, I'm doing 4 here. So I will do 4 here, and then I think I'll have to color them with a different color. So yeah, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. I think I got the pattern. I got the pattern. I'll just add. I'll just add add four more. So every time I'm adding four more. Now I will try to answer. Initially, I will try to answer in O of n. Let's try. Let's see. So integer answer equals to 1. I will do n minus minus because the first one is always that. So while I could actually use minus minus n instead of this. While minus minus n, I will just add answer plus equals to. Okay, I will keep another variable x equals to 4. So I will do answer plus equals to x and x plus equals to 4. Yeah, that should be my answers. I should keep a long here. Yeah, it should work. Let's say. So this is O of n solution. Yeah, it worked. O of n solution worked. So I'll try to make it O of 1 solution. Can I optimize it like that? So I think I can. I'll just have to find a parent. So I'm adding 4 more every time. So what do I do? 4 plus, so 4, if I sum it up, there will be 12. If I sum it up, there will be 12, 12, 24, then 40. Now, do I see a pattern? 1 times 4 is 4, 2 times 4 is not 12 definitely, 3 times 4 is not 24, so 4 into 4 into 4 into something, there is 4 into, let's say 4 into 2 to the power 2 to the power n maybe. So 4 into n minus 1 maybe. Okay. So 4 into 1, then 4 into, or maybe 4 into n minus 1. Is it 4 into n minus 1? N plus 1 maybe, I don't know. 4 into, so this is 4 into n 1, 4 into, okay, no, I'll have to check here. So 4 into 1, then 4 into 1, then 4 into 3, then 4 times 6, then 4 times 10. Okay, it's hard to find a pattern. It is definitely hard to find a pattern here. What can I do to optimize it? What can I do? Should I do something like 4 to the power 4 to the power? Not really. So 1, then 2 added, then 3 added, then 4 added. Alright. So this is basically 1, 3, 6, 10. I'll have to get a pattern from here, I think. So that is 2 into n minus 1, is it? So let's say 2 into 1 minus 1 is 1. 3 into 2 into 3 minus 1 is not definitely that. 2 2 into n minus 2 into, yeah, the 2 into 2 minus 1 is 3. 2 into 3, 2 into 3 minus 1 is not 6. So no, that's not the case. What is it? What is it? What is it? 4, 8, 12, 16. I don't know. 4, 8, 12, 16. So 4, 12, 24, 40. 4, 12, 24, 40. Let's get rid of everything and let's rewrite it again. 4, 12, 24, 40. 4, 12, 24 and 40. And 1 before that. Here is 4 times 1, 4 times 3, 4 times 6, 4 times 10. adding 1, then adding 2, n into something, n into n minus 1, something like that, maybe something like that. Ah, I don't think, it is something like that. 1 into, no, 2 into 1, so that's, yeah, 2 into 1, then 3 into, if I look for 2, if I look for 2, then 2 into 2 minus 1, so 2 by 2, this is 1, so 2 and 2 is crossed out, so that's okay. But for 3, that's 3 into 2, 6, 6 by 2 is 3, then 4 into 3 is 12, 4 into 3 is 12, 12 by 2 is 6, 5 into 4 is 24, then 2. So I got the formula. Yeah, I got the formula. I got the formula. Now I'll just have to write the code, which is okay. So let me explain first. So what I am doing here is I got a formula to calculate these. These are the numbers which I will multiply with 4. So for example, if I am given 1, then what will give me? What will it give me? 1 into 0 minus 2. So this is 0. This is 0. So I cannot do that, can I? I cannot do that. So for the initial case, I will have to answer directly 1. And for the rest of the cases, for n with n greater than 1, I will just apply this formula. So for n greater than 1, so let's say 2, so this is n equals to 2, so I will do 2 into 1 divided by 2 according to this formula, and then 1 into 4, which is 4. Okay, and for 3, I will do 3 into 2 divided by 2, and here I got 3, so 3 into 4, and this is 12. So this works for all other n, and let's write the code now. So I have one base condition, which is if n equals to 1, maybe I can do a ternary operation here, return, okay, no, answer equals to, uh, uh, okay, let's do the ternary. N equals to 1, then 1, else there will be n into n minus 1 divided by 2. So I can do something like 2 and 4, which is 2. I'll just to multiply it with 2. That should work. That definitely should work. And I'll return the answer. Let's say wrong answer. Expected 5. Expected 5. So okay, I think yeah, I'll just do this and do this. Yeah. So I gotta okay, runtime error. Why did you get a runtime error? Because we are taking maybe this is why we are getting a runtime error. Okay. Yeah. So okay, so I got two errors that I didn't explain. The last one was integer. So when I'm trying to multiply integer with we like this. So we are multiplying, we are taking n, then we are multiplying some number with it, and when we are multiplying with it, so it is becoming out of range. So it is overflowing because it was declared integer. So that's why I made it long, and it worked. And before that I got another error, not error, another wrong answer. That was because of because uh, I was directly answering 1, And for these I was directly answering whatever I'm getting from this formula, but I had to add 1 with it. So yeah, it worked for every other formula. So let me rewrite this. Let me explain one more time. Clean, more neat and clean with. So here I had 1. So my formula is 2 n into n plus n into n minus 1 divided by 2. So so and I'm multiplying 4, and I optimized it like this because I can take only 2, so I optimized it there. So I'll write the optimized one. So n into n minus 1 into 2. So and what I'm getting from here, so for n equals to 1 I'm getting 1 into 0 into 2. So 1 into 0 into 2 is 0. So for 1 I'm getting 0, and I had to add 1 with it. So 0 plus 1 is 1, which is our answer. And for n equals to 2, I am applying this formula. So 2 into 2 minus 1 is 1 into 2. So that's 4. So I'm getting 4, and 4 is not my answer. I have to answer 5 because initially I had 1 and I'm adding 4 more with it. So 5. So I'm adding 1 here. So everything whatever I'm getting from this formula, I'm having to add 1. That's what I'm doing here. I am calculating it, and then I'm returning after adding 1. So that's my O of 1 solution. It took a longer time. It took a longer time to find the optimized solution. Okay, but yeah, this was pretty easy. This was pretty easy. Yeah, it was just pretty easy.